Hello and welcome to SUSECON Digital 2022. My name is Robert Schweikert and thank you for joining me today as we talk about a deep dive into the public cloud update infrastructure. Today I will talk about what the update infrastructure is. We will follow the network traffic to see how the pieces fit together, and then I will provide a summary of the highlights of the presentation. Once again, thank you very much for joining me today. A few words about myself. My name is Robert Schweikert. I've been with SUSE for a little more than 13 years. I started out in the ISV team, and for the last 10 or so years, I've been focused on the public cloud. On the personal note, I am an avid motorcycle rider and a soccer and Formula One fan. Let's talk about the update infrastructure and what the update infrastructure is. The update infrastructure itself is a set of servers that run in various public cloud frameworks. The servers themselves are arranged in a cloud infrastructure independent architecture, so they can run in any cloud. SUSE operates the update infrastructure in AWS EC2, Microsoft Azure, and Google Compute Engine. The update infrastructure provides bug and security updates for SUSE BYOS and on-demand instances for SUSE Linux Enterprise products, such as SUSE Linux Enterprise Server, SUSE Linux Enterprise Server for SAP applications. By the numbers, there are two types of servers that are part of the update infrastructure. One set of servers is known as the region servers, and the other set is known as the update servers. There are 17 region servers across AWS, Azure, and Google, and 274 update servers across AWS, Azure, and Google. The number of update servers keeps growing as the CSPs add additional regions and availability zones. The region servers themselves, the implementation is open source. You can see the GitHub link up in the upper right-hand corner. The region servers provide a mapping of the regions around the world in any given framework to the update servers in that region or geographically close to that region. This mapping happens via a region hint that is sent from the client or via the IP address of the client. And the client in this case is your instance that is accessing the update infrastructure. The update servers use RMT technology. RMT is a repository management tool, an open source project by SUSE. And again, you can see the GitHub link in the upper right-hand corner. The servers are set up in an AHA configuration. There are at least 3 servers per region, and these are spread across availability zones where possible. The servers communicate with each other to share the client information, and the systems themselves are completely independent, such that there is no single point of failure. Each update server also does independent access verification. That means client information is evaluated to ensure that the client is eligible to access the repositories that the update servers provides. A few words about the access verification. Access verification happens by validating information that is provided from IMDS of the instance. IMDS is an instance metadata service that is accessible from every instance that runs in one of the partner frameworks. It is possible to disable that access, but once you disable that access, you can also not update the update infrastructure. Information from IMDS is collected by metadata tools. So there's a tool for Azure, there's one for EC2, and there's one for Google. You can see the GitHub links here if you're interested in the source code. These tools are built into the images that SUSE publishes, and the data is sent for on-demand images. That happens automatically, and for BYOS instances as well if you're running the guest register executable. More on this in a little while. Verification itself is framework dependent for pay-as-you-go instances. So in EC2 and in Azure, the verification involves metadata signature verification. And in Google, there's a GCP-provided API that is used to verify access eligibility of the instance. The BYOS in access verification is independent, framework independent, as the update server reaches back to the SUSE Customer Center and verifies the registration code that you provide. A few words about monitoring of the update infrastructure. All servers are monitored 24/7 by a dedicated sysadmin team, and the servers have defined wake-up events. Here's a list of just a few of the categories or metrics that we monitor. In addition, we also monitor CPU load, and when we, see there is a large number as more clients are registered and updates happen more often, we also increase the sizes of the update servers. From a setup perspective, the region servers are randomly distributed across various regions in any given framework. There are no set rules. Update servers are placed generally in every region. Again, this is somewhat framework dependent. For regions that have no update infrastructure, traffic gets redirected to geographically closest region. So let's follow the network traffic to see how all these pieces fit together. Everything starts with the client, meaning this is your instance. For pay-as-you-go instances, the connection is automatically initiated by the guest register service. The guest register service is enabled, as I mentioned, by default in the pay-as-you-go images that SUSE provides. For BYOS instances, this service is not enabled by default, and it should not be enabled by default, because for BYOS instance registrations, you need the registration code, and there is no automatic way to get this to the service. The service itself short circuits if the instance is already registered. So when you shut down a registered instance and you reboot it and you bring it back up, the registration process does not take place again. It recognizes that the system's already registered, and basically nothing happens. The steps are relatively simple. The initial contact is to one of the region servers, and then from there, what the region server provides is cached, and we'll talk about this in a minute. And the region server list is built into the images, both pay-as-you-go and on demand. And there are these, the images contain these framework-specific packages that provide the configuration for the guest register service. Once the client reaches out to the region server, it receives certain information about the update infrastructure, and that information is then cached locally on your system. So we contact one of the update servers and get the server certificate. This initial contact happens over unverified HTTPS. Once we receive the certificate from the update server, we verify that certificate signature matches the signature we received from the region server. If these signatures match, then the certificate that we have from the update server gets added to the chain of trust to the system. Once this happens, all traffic switches over to verified HTTPS traffic. So the client then, after this initial step, sends the client information to the update server where it is verified. For BYOS instances, we send the client information plus the registration code as provided on the command line. And BYOS instances also get added to SEC, while on-demand instances do not show up in SEC. BYOS instances then count against your subscription, while on-demand instances do not count against your subscription since they are pay-as-you-go. and your subscription is handled through the billing of the cloud service provider. The traffic, as I mentioned, is all port 443 HTTPS. So port 443 must be open in your network construct in which the instance is running. All update servers for a given region must be accessible. Also, all region servers must be accessible. So if you're listing specific IP addresses for traffic that you allow egress to from your network construct in the cloud service provider, you can find that information using Pine. You can also access the update infrastructure if you're routing the traffic through your data center and through your firewall appliance in your data center. A few more words about the region server. All traffic to the region server is encrypted. Again, port 443 must be open. You can find the server IPs with Pine or at pine.suse.com. The server certs of the region servers are built into the SUSE images. All certificates in the update infrastructure are self-signed, and also all names in the update infrastructure are not DNS resolvable. Okay. As mentioned previously, the client sends a region hint. That region hint is used by the region server to look up what update servers about the information that should be sent back to the client, the update server information. If the region hint is not available, or it is a region that is not yet known to the region server, then we fall back to IP lookup. And then once we have all the information from the client, the region server sends back a non-resolvable DNS name for all the update servers in a given region. It provides the update server IP, and it provides the update server fingerprint. And this is how we get the verification. The region server provides the update server certificate fingerprint, and from the update server, we download the certificate, and then we compare those fingerprints, and that closes the chain of trust. Generally, when things go wrong, 99% of the time, this is a network setup issue on the client side. That's meaning the network construct within which the client runs is not configured in the way that is required to access the update infrastructure. It could be that the update server infrastructure IPs are not trusted. There is no port 443 may not be open for the instance. There may be man-in-the-middle firewall filtering. There may be a non-transparent proxy. Most of the time, these issues can be found by looking at varlog cloud register. Again, all certificates of the update infrastructure servers are privately signed, so they're self-signed certificates, and the names of the servers in the update infrastructure are non-DNS resolvable. Then there are other failure modes. So this mostly happens on update, rarely during registration. We have a thundering herd problem. All update servers are shared with everybody in a given region. So, if you have a large number of servers that are all trying to get updates at the same time, you may have to deal with network timeouts. So you have to do retries. There is currently no auto-scaling in the update infrastructure design. As we noticed that, we have an increasing number of systems registered, and they're all coming to visit us at the same time. We upgrade the instance types of the update servers since the update process is CPU bound. So we're keeping up with this, but this problem exists. So just be aware if you're sending a very large number of servers to the update infrastructure all at the same time, you may get some timeouts, and you might have to retry those updates. Sharding generally works, and we're looking into ways to alleviate this problem, but this is a longer-term process that has just started. What else happens? The Cloud Region Server Client package also provides a server plugin. That plugin handles failover in a transparent way. So should the target update server be unavailable, then the plugin will automatically switch the target server to one of the other update servers based on the information that is cached. And the super plugin supplies the necessary data for access verification. So in summary, the update infrastructure provides updates to SLE-based on-demand instances in AWS, Azure, and GCP. BYOS instances can also be registered to the update infrastructure. There is a blog about this on the SUSE community side. Please take a look there if you're interested in this functionality. The update infrastructure is maintained by SUSE and is monitored 24/7 by a dedicated SUSE administration team. Client registration is automatic for pay-as-you-go instances. Don't mess with the setup of the repositories. Something will go wrong. You can add your own repositories. Those are not affected by what the automation does in the registration or the maintenance of the update infrastructure repositories. Again, from a network perspective, port 443 must be open. Traffic to the SUSE service via internet must be allowed. Don't use man-in-the-middle inspection, and use Pine to find the server IPs. And with that, thank you very much for your attention. This was a quick overview of the update infrastructure and how the pieces fit together. Thank you very much and enjoy the rest of SUSECON Digital 2022.